Why are we doing ETL process? Customers are increasingly focusing on the collection and organization of data for strategic decision-making. The ability to review historical trends and monitor near real-time operational data has become a key competitive advantage. General goals of testing an ETL application. 1. Data completeness ensures that all expected data is loaded. 2. Data transformation ensures that all data is transformed correctly according to business rules and/or design specifications. 3. Data quality ensures that the ETL application correctly rejects, substitutes default values, corrects or ignores and reports invalid data. 4. Performance and scalability ensures that data loads and queries perform within expected time frames and that the technical architecture is scalable. 5. Integration testing ensures that the ETL process functions well with other upstream and downstream processes. 6. User acceptance testing ensures the solution meets users' current expectations and anticipates their future expectations. 7. Regression testing ensures existing functionality remains intact each time a new release of code is completed. 1. Data completeness. One of the most basic tests of data completeness is to verify that all expected data loads into the data warehouse. This includes validating that all records, all fields and the full contents of each field are loaded. Some of the strategies to consider include a. Comparing record counts between source data, data loaded to the warehouse and rejected records. B. Comparing unique values of key fields between source data and data loaded to the warehouse. This is a valuable technique that points out a variety of possible data errors without doing a full validation on all fields. 2. Data transformation. Validating that data is transformed correctly based on business rules can be the most complex part of testing an ETL application with significant transformation logic. Here are some simple automated data movement techniques. A. Validate correct processing of ETL-generated fields such as surrogate keys. B. Validate that data types in the warehouse are as specified in the design and/or the data model. C. Validate parent-to-child relationships in the data. Set up data scenarios that test how often child records are handled. 3. Data quality. Data quality is defined as how the ETL system handles data rejection, substitution, correction and notification without modifying data. To ensure success in testing data quality, include as many data scenarios as possible. Typically, data quality rules are defined during design, for example, a. Reject the record if a certain decimal field has nonnumeric data. B. Substitute null if a certain decimal field has nonnumeric data. C. Validate and correct the state field if necessary based on the zip code. 4. Performance and scalability. As the volume of data in a data warehouse grows, ETL load times can be expected to increase, and performance of queries can be expected to degrade. This can be mitigated by having a solid technical architecture and good ETL design. The aim of the performance testing is to point out any potential weaknesses in the ETL design, for example, a. Monitor the timing of the reject process and consider how large volumes of rejected data will be handled. B. Compare these ETL loading times to loads performed with a smaller amount of data to anticipate scalability issues. 5. Integration testing. Typically, system testing only includes testing within the ETL application. The endpoints for system testing are the input and output of the ETL code being tested. Integration testing shows how the application fits into the overall flow of all upstream and downstream applications. When creating integration test scenarios, Consider how the overall process can break and focus on touch points between applications rather than within one application. Most issues found during integration testing are either data related to or resulting from false assumptions about the design of another application. 6. User acceptance testing. The main reason for building a data warehouse application is to make data available to business users. Users know the data best, and their participation in the testing effort is a key component to the success of a data warehouse. Implementation. User acceptance testing, also known as UAT, typically focuses on data loaded to the data warehouse. 7. Regression testing. Regression testing is revalidation of existing functionality with each new release of code. When building test cases, remember that they will likely be executed multiple times as new releases are created due to defect fixes, enhancements, or upstream systems changes. Building automation during system testing will make the process of regression testing much smoother. Test cases should be prioritized by risk in order to help determine which need to be rerun for each new release. A simple but effective and efficient strategy to retest basic functionality is to store source datasets and results from successful runs of the code and compare new test results with previous runs. For training, support and consulting inquiries, call us, India, +91 997 799 7254, USA, +1 772 228 6064, mail, training@bispsolutions.com, www.bispsolutions.com, training@bispsolutions.com.